Good afternoon. I'm going to give my lecture in English. I hope you can all understand me. In these few minutes, I'm going to tell you a little bit about the Panama Canal, how it's been working, where we're looking into the future, and what, more or less, what the business of the Panama Canal is like. First, let me start by showing you how the Panama Canal works. Panama Canal is like a water elevator, having 3 locks that use fresh water from the lakes. They actually raise the vessels from ocean level in 3 steps on the Atlantic side to the Gatun Lake, which is approximately 27 meters above sea level. It transits through the lake, through the Continental Divide, and goes into the Pedro Miguel locks, where it goes down 9 meters, and then into the Miraflores Lake, where it reaches the Miraflores locks, where it goes down 2 steps of 9 meters into the Pacific Ocean. This is also reversible. So that's how the canal was designed more than 100 years ago, and it's still working. Now, let's see how the new locks will work.
The expanded canal consists of 2 new set of locks. One on the Atlantic side, named Agua Clara locks. One on the Pacific side, named Cocoli locks. A new Panamax vessel has a beam of up to 49 meters and an overall length of up to 366 meters and a draft of up to 15 meters in tropical freshwater. The dimensions of the chambers of the new Panama Canal locks are 427 meters of usable length when both guarding gates are closed, with a width of 55 meters and a depth of 18.3 meters. The lockage through the new locks will not require locomotives and will be very similar to those of the Barendrecht and St. Bliet locks in the port of Antwerp, Belgium. For a better understanding of the transit procedure, we will take you on an imaginary transit on board a new Panamax vessel heading north from the Pacific to the Atlantic through the new locks of the expanded Panama Canal. Upon arrival to Panama Canal waters, the ship's captain will contact Flamenco Signal Station, where he will be informed of the anchorage area and the estimated time of arrival, or ETA, of the Panama Canal pilot to begin the transit. Once the vessel is anchored, the ACP boarding officer, the transit vessel inspector, the industrial hygienist, the chemist, and the port captain will conduct their respective inspections on board the vessel. These inspections will ensure that optimal conditions are met in order to guarantee a safe transit. After these inspections are completed, the new Panamax vessel will be scheduled for transit, and a Panama Canal pilot will board the vessel to take it on its northbound transit through the Panama Canal. Right after boarding, the Panama Canal pilot receives the transit information. Transit begins from either the Pacific anchorage or from the merchant or explosives anchorage areas, depending on the vessel's cargo. The vessel will enter the navigational channel from the Pacific entrance using the vessel's engines and rudder. With the vessel on its way to the new Panamax locks in the Pacific, named Cocoli locks, the Panama Canal line handlers board the vessel around buoy 14 and prepare the resources required for the lockage, mainly lines, capstans, chocks, bits, ship's crew, among others. At that time, around buoy 16, the vessel will receive its first assisting tugboat. Upon arrival to Dock 6 in Balboa, north of the Bridge of the Americas, the vessel receives its second tugboat. These 2 tugboats will assist the vessel throughout the entire lockage. At the same time, the second Panama Canal pilot will come aboard, and the vessel will receive the 3rd and 4th tugboats to assist in the process of arriving and entering the locks. When the vessel arrives at the approach structure of Cocoli locks with tugboat assistance and the use of vessel's engines and rudder, the vessel will be aligned to enter the lock's lower chamber, when the 3rd and 4th tugboats will be released. The 1st and 2nd tugboats will continue to assist the vessel as it enters the locks and through the lockage. When in position within the lock chamber, Panama Canal line handlers, with the support of the ship's crew, will begin to secure the vessel with the use of 4 lines that will be sent out from the vessel, mainly a headline and spring line forward, and a stern line and a spring line aft to the lock center wall, opposite to the water-saving basins. The lines will be received by the lock's mooring personnel, who will secure them to the bollards destined for this operation, both in the bow and the stern. The filling of the lock chamber begins after the vessel is safely secured. Once the chamber is filled, the lock gates open to allow access to the middle chamber. After the lock gates are open and the lines cast off, the vessel moves using its engines and rudder and the assistance of the tugboats. Once the vessel is inside the middle chamber, the process of mooring the vessel to the lock wall is repeated, and this process is again repeated in the upper chamber. As soon as the vessel departs Cocoli locks, the second tugboat, which is made up on the bow, is released and the line handlers disembark. The vessel will continue its transit through Culebra Cut, assisted by the first tugboat, which is made up on the stern. The tugboat will continue assistance until Chagres Crossing, near Gamboa, where it will be released. From this point on, the vessel will navigate through Gatun Lake by itself. At buoy 13 in Gatun Reach, the line handlers will board the vessel, and by buoy 11, the vessel will receive the first tugboat, which will assist in the lockage through the new Panamax locks in the Atlantic, named Aguas Claras locks. During its passage through Gatun Anchorage and in transit to Aguas Claras locks, the second, third, and fourth tugboats will arrive and assist the vessel while entering the lock's upper chamber. Unlike the Pacific locks, the south entrance of Agua Clara locks does not have an approach structure. Therefore, alignment with the upper chamber will be performed solely with the assistance of tugboats and the ship's engines and rudder. Once aligned, the vessel will begin entering the upper chamber of the lock. As it enters, the third and fourth tugboats are released. The vessel will continue its entry with the assistance of the first and second tugboats. Inside the chamber, and when in the correct position, lines will be sent out to secure the vessel to the chamber center wall, opposite to the water-saving basins. Panama Canal line handlers, with the support of the ship's crew, will send out 4 lines, mainly a headline and a spring line forward, and a stern line and a spring line aft. The lock's mooring personnel will secure the lines to the bollards destined for this operation, both in the bow and stern. After the vessel is secured to the lock wall, the chamber will begin to be emptied. As soon as the water level for the next chamber is equalized, the lock gates open to allow access to the middle chamber. Once the lock gates are completely open and the lines are cast off, the vessel begins to move to the next chamber. In this case, the middle chamber, using engines and rudder and the support of tugboats. When the vessel is in position in the middle chamber, the process of mooring and moving will be repeated, and repeated once more when in the lower chamber. As soon as the vessel exits Agua Clara locks, the second tugboat, which is made up on the bow, will be released. While proceeding down the Atlantic entrance reach, the first tugboat, which is made up on the stern, will be released and the line handlers disembark. The vessel continues its transit towards the Atlantic breakwater and navigating towards the exterior Atlantic Axis Channel, which is approximately 1.5 nautical miles long, and then out to sea and to her final destination.
Okay, for comparison purposes, we have here the dimensions of the existing canal locks. One chamber is approximately 305 meters length and 33.5 meters width, and allows vessels with a draft of 12 meters. The new lock will be significantly larger. It will be 427 meters of length, 55 meters of width, and will allow vessels of 15.2 meters of draft. For other comparison is that the maximum vessel carrying containers that can go through the existing locks can carry up to 4,400 TEUs. There are already vessels been built and designed that go over 13,000 TEUs for the new locks. So we expect somewhere between 13 and 14,000 TEU vessels to be able to transit the new Panama Canal locks.
The Panama Canal, the path that transformed international trade standards. Today, the waterway is preparing the delivery of the expanded Panama Canal. A third lane is built for the transit of large Neo-Panamax vessels, while the navigational channels are deepened and widened. 2015 is a decisive year for the expansion. With more than half of the job done, the masterwork enters its final leg. The third set of locks project, the expansion's most complex, is now focused on electromechanical installation that will take the project into its final stage. The installation of 16 rolling gates began in December 2014, with their insertion into the lockheads in the Atlantic and Pacific complexes. At the same time, the project continues with the installation of the 152 valves that will control the water flow in the culverts and chambers. The construction of 32 buildings continues, as the poured concrete volume reaches over 4 million cubic meters and the water-saving basins, which will allow a 7% less water usage than the current locks, are clearly defined. 3 dams are being built at the north end of the Pacific Side project. One of them has been completed, and the remaining 2 are on their final phase. The filling of the locks began this year, marking the start of the compliance and operation testing period. The encounter between the new locks in Cocoli and the Pacific Ocean took place in August with the breakdown of the southern plug. In the Pacific Access Channel, a few meters from the lock's dams, lies another important structure of the expanded canal, Borinquen 1E, a 2.3-kilometer-long dam located west of the Pedro Miguel locks. It will work as a barrier between the current navigation channel and the access to the third set of locks. This new access, known as the Pacific Access Channel, will be 9 meters higher than the Miraflores Lake. 50 million cubic meters of dirt and rock were excavated from the entrance of the Culebra Cut to the new locks in order to create a new navigation channel. Culebra Cut, the historical 13-kilometer-long strip, has been dredged to deepen and make it fit for the navigation of larger ships. A similar task is being carried out on Gatun Lake, which was the largest artificial lake at the time of its creation. Its navigational course is being widened and deepened by Panama Canal dredging forces. To ensure safe and expedite navigation, a total of 33 range towers are being erected to replace the lighthouses along its banks. Gatun Lake's maximum operating level will be raised 45 centimeters to improve water supply for the expanded canal operations. This will add 200 million cubic meters of water to our reservoir. 7 years have passed since the inauguration of the Panama Canal expansion program initiated, and it continues forward at full speed. The expanded canal is now in its countdown phase, where every component, every cubic meter of concrete, of excavated and dredged rock contributes to the progress of the flagship project of our young nation. A century after its inauguration, the Panama Canal will give the world a wider path between the seas.
Okay, just to mention that the new locks will use water recycling basins, a system of 3 basins per chamber that will allow this lock to be more water efficient than the existing locks. Even though these new locks are significantly larger than the old locks, they will use less water because on each lockage they will recycle 60% of the water, making it even more efficient in water use than the existing locks. Here I'm going to show you a sequence of pictures of the Pacific Access Channel, Phase 4, which connects the Cocoli lock, which is the Pacific side lock, with the Gatun Lake. This is where the Borinquen Dam was built. It's almost finished. This is a project that's already 92.4% complete. A sequence of pictures will show you how it was before. Before we started the project, there was a hill on the way of the new channel. We wanted to connect the Pacific Ocean with the Gatun Lake, and there was this thing here. So we had to dig a channel through the mountain. This was probably 2006. So we started digging. We took out the hill. These pictures show sequentially the progress of the excavation. It was done by a contractor. And you can see the progress. No more hill. And at the far end, the construction of the new locks. Over here is the Borinquen Dam, and this is the channel. And this is how it looks today. There's only, this is already 90-something% done, the excavation on this side. Here's a plug that has to be removed to connect the Gatun Lake to the access channel to the lock. And this is actually in progress at this moment. We're blasting and excavating this plug. The plug on the other side of the lock, as you saw on the movie, has already been removed. So the Cocoli lock is already connected to the Pacific Ocean. It's going to be connected to the Gatun Lake very soon. These are other projects. This is on the Atlantic side, all the excavation and widening of the channel. This is the channel for the Neo-Panamax lock. This is the channel for the existing lock. All this has been widened and deepened to allow for the new vessels, new Panamax vessels to come in. And over here you can see, this is probably a month-old picture or more, where we're building a new bridge to cross the canal on the Atlantic side. Okay, let me tell you about our business a little bit. This is how, starting 1914, when the canal was inaugurated, until 2 years ago, how transits increased during time until we reached 15,000 transits approximately by the 60s, the 1960s. After that, pretty much didn't change. A little bit up, a little bit down, but remained between 14 and 15,000 transits of vessels through the Panama Canal per year. But the cargo that went through was not the same. The yellow line shows on the right-hand side axis the tonnage in millions of CP swab. That's our measurement unit. This is how the tonnage grew, spiked here in the 80s, came down again, and kept growing, and hasn't stopped growing. This is why by the early 2000, we saw that the canal, okay, first question is, how come without increasing the number of transit, we increase the tonnage? Because the average size of the ship kept growing. The industry was adapting to the Panama Canal. The industry was building larger and larger ships. So the average ship by the year 1955 could carry 4.8 thousand tons. By the year 2014, the average ship was several times bigger than that one. So this is how the industry was adapting. So we saw this coming, and we knew that we were going to be without capacity very soon. The industry was making bigger and bigger vessels, and we had a limitation on the size of the vessel that could transit the Panama Canal. So early the year 2000, 2003, 2004, we started making studies of the new set of locks. And then we made the decision. We need to build a new lock that can accommodate what the industry is going to build. If not, we're going to stay with a canal that cannot grow. And we couldn't do that because Panama is a very small country, 3.6 million people live in Panama only. And Panama, the economy of Panama depends a lot on the canal. So we had to do something about it. This is a closer view from 2004 to 2014, how the transits occurred during these years. You can see, sorry, the tons. The tons are the bars, 200 tons, 250, 300, a million tons. That's no dollar sign there. That's not good. Tonnage cargo. Okay, this is the This is the number of transits remained close to 14, and the tonnage near 300 million tons. The tolls, which is the revenue we get from the vessels, is this a year. We get this year we're going to be very close to $2 billion in income for the Panama Canal through tolls only. The number of transit has not increased. And because we cannot change the tonnage, the vessels already grown to the maximum dimensions, the Panamax dimension of the Panama Canal. So now we have to bring into the show the new set of locks so we can keep growing. To give you an example, what the Panama Canal represents to the country, to Panama. This is how much income contributions to the Panama Canal to the Panama economy was given by the canal. From 1913 to the year 2000, during the U.S. management of the Panama Canal, $1.8 billion were given to the country. During the 14 years that Panama has managed the canal, we have given the country for $8.6 billion, 4.6 times that much money. So as you can see, this is a big deal for Panama. The Panama Canal is like the motor that moves the economy of the country. So we have to keep it growing and providing for the growth of the country.
Thanks to its geographical location, connectivity, and modern infrastructure, Panama is a major multimodal transportation and logistics center. The Panama Canal expansion drives the increase in cargo flows, strengthening even further the conglomerate of logistics and transportation services, as well as Panama's business potential and competitive advantage in the region. Today, Panama ranks first in container movements in Latin America and has become the focal point for cargo shipments to America. The Panama Canal is 80 kilometers long and has ports on both oceans. These ports currently provide a wide range of services and facilities for cargo transshipment, handling, and distribution, as well as new alternatives for the transportation of containers from one ocean to the other, and logistics parks that offer a wide range of value-added services. Some of the areas for new business development include terminals for regasification and storage of liquefied natural gas for power generation and supply to ships. Top-off activities to transfer dry bulk such as coal. And shipyards specialized in ship repair. The Panama Canal expansion is the catalyst for the development of the logistics and transportation conglomerate, increases global and regional cargo movements, and offers a variety of services to ship owners, shippers, manufacturers, and suppliers.
Okay, that's a broad view of what the Panama Canal represents for the country. Many times I've heard that they refer to Panama as a port with sides to both oceans. It's so narrow, the distance between the two oceans, and the canal makes it so easy that it's actually like having a port with set on two different oceans, the Pacific and the Atlantic. Let me tell you a little bit of the dredging work. I think probably this, other than the business itself, will be of your interest. I have with me Rogelio Gordon. He's a executive manager of the dredging division. Any question on this, I'll let him answer. So, dredging division has been very active in the expansion program. And most of the digging of the inland waters and the dredging has been done by the dredging division. This is where the dredging division headquarters is, at the Gamboa office. When you go there in 2018 for the next meeting, I'm sure you can go take a trip to Gamboa and see the dredging division and visit our equipment over there. This is one of the big projects the dredging division did. Is a dredging of 9.5 million cubic meters was done on the widening of the Gaylor Cut. This Gaylor Cut was 630 feet wide and was expanded to 715 feet. They had to blast 11.7 million cubic meters of rock. It was completed last year by December. This is a Gaylor Cut. The Gaylor Cut was also widened it was dug deeper and widened in two separate programs. For the widening, it was done by the same equipment, but two different projects. So this different views of the same Gaylor Cut. Okay, there you go. Gaylor Cut in Gatun Lake. The Gatun Lake also had to be deepened. The dredging division did the work of digging out 17 million cubic meters on this project. It was completed last January. You can see the pictures here for our equipment doing all the dredging. Widening and deepening of the Pacific entrance and south approach channel to the third Sutter Lock. This was done by a contractor, Dredging International. They had to remove 9.1 million cubic meters of dirt and rock. It was completed in January 2013. Some views of where the job was done. There's the Pacific entrance channel. There's the Bridge of the Americas. All this was dug, and that's equipment by the contractor. Also, widening and deepening of the Atlantic entrance was done, and the north approach channel of third Sutter Locks was done by a contractor. In this case, it was Jean Denou. They had to remove 23.4 million cubic meters, and it was widened in separate sections to 225 meters wide, 300 meters in another section, and 520 meters in another section. It was completed also in January 2013. The widening of the reaches of Basso Obispo and expansion of the Gamboa mooring areas. Basso Obispo and Gamboa, this is a dredging division, is north of the Gaylor Cut. This is a project that is all now in progress. It has recently started. It's been done by our own forces at the dredging division. Has to be 10.4 million cubic meters have to be dug. 3.9 will be dredged and 1.3 will be blasted. Some of that also can be excavated from the dry. The progress at this moment is 37%. Some other work done by the dredging division in Panama. in the Panama Canal, the excavation for the new fueling facilities at the Pacific side at Miraflores, where we're going to build a dock for downloading fuel for the power plants and fuel for our floating equipment. The excavated volume was 0.7 million cubic meters and blasted 0.44 million cubic meters. It will be completed by this month. Thank you. Good. Okay, as I said before, the Pacific Access Channel, the north plug, this is actually part of the canal expansion. There we have to dig a volume of 0.74 million cubic meters. We started a couple months ago, and will be finished by January. It's in progress at this moment by the dredging division. The Atlantic Access Channel south plug. This is the Atlantic side. This is the Atlantic Ocean, Caribbean Ocean. This is the Agua Clara lock. You can see it almost complete. It's already been flooded. This is a very recent picture. The water-saving basins are finished. All that remains to be finished are some of the buildings and the testing of the equipment. All the gates are being tested and the valves are being tested. The job by the dredging division equipment here is a Kibian dredge, is to remove these plug. The plug will actually separates the lock from the Gatun Lake. Once we remove it, we can actually use the lock. Some of the jobs by the dredging division, we have to use, let me see if I can have it here. Yeah, here in this lake, we are going to provide for the new anchorage area for the vessels in transit. And we have to provide 5 more mooring areas for vessels, anchoring areas for vessels. So we have to first remove all the trees that are submerged there and then dredge this area. So this is a job also for the dredging division. Already going to be starting, the dredging will start next year, but at this moment we're doing some tests to find the best solution for removing the trees, the submerged trees. Okay, some other work by our own people. The maintenance of the Miraflores approach and Gamboa Reach. This was done by a contractor. We hired Dredging International for a dredging of 1.8 million cubic meters at the entrance of the canal on the Pacific side. This is some of the work done by one of the dredges at the lock approaches, at the Miraflores lock. This is also one of our dredges removing debris from downstream of the Miraflores lock. This is some of the debris they catch downstream of the locks. Some of the works that the dredging division has to do is the pick up the slides. We don't have as many slides as we used to have. Panama Canal has learned a lot in 100 years of slides, so we can more or less predict when a slide is going to happen. We have a lot of instruments that can measure. So we do some earthwork to protect an area that's unstable, but once in a while we have a small slide that can go into the water. Hopefully it hasn't happened recently that the slide blocks the canal. The last time that happened was in 1980s, I think. 1980s, hasn't happened recently. So we do a lot of that maintenance work. We do a lot of erosion protection on the banks to prevent the slides. Aids to navigation. Rogelio, I'm sure is going to talk about this later. Aids to navigation, we maintain all the aids to navigation, the buoys, the lights, the lighthouses. Some of our major equipment here, dredging equipment, we have 4 dredges. The suction cutter dredge, Mindy, it's a very old dredge, but still works. Let me go back. Okay, the Mindy was built in 1943. It's still working. The dredge Kibian, suction dredge also, suction cutter dredge, is new. It was bought in 2011. It's a picture of the Kibian dredge. The Rialto Christensen is built in 1978, still working. Is the Rialto Christensen? Again. Okay. And the Alberto Aluman Subieta was named after our previous canal administrator, Mr. Alemán Subieta. It's a bucket shovel, was bought in 2014 as the newest of our dredges. Other than that, we have two drill boats for drilling and blasting. One is very old, the Thor, and the newest is the Baru was built in the Panama Canal dock. We have some lifting equipment. Some of that old equipment still works fine. And tugs to assist, and barges to assist the work of the dredging division. And with that, I finish my presentation. I'll be happy to answer your questions.